In an older video I made, I discussed 3D printing and its relations to the DIY movement. Check out the video if you would like. Here, I will discuss the recycling movements and the materials, especially hydrocarbons, being used. But before, we need to be reminded of the ways for making 3D models. First is by using modeling softwares. The best are Autodesk or AutoCAD softwares. These are super accurate, easy to learn and to use. Or Ultimator Cura software for making STL files and CAD files. Don't use something like Blender because it's not for printing. It's for doing video games or animations. In the end, something will be printed, like this one is a 2x4 Lego brick with an equation of, and with little of creativity we'll get this Hulk made of Lego bricks after of course printing the bricks using for instance ABS filaments. ABS is the polymerization of acrylonitrile butadiene styrene with physical properties written here on the table. The other way for modeling is to fight with me for accurate coordinates by finding the mathematical equation. Then you push the print button directly and you get the desired product. Like this is a glass of water if you want to print a useful thing. Of course you can add to the print the transparency feature if you want, using transparent filaments. We'll get into that later. Finally is by scanning, and here again you need a software like Cura. And the software gives you the option of feeding it with photographs of 360 degrees. Ideally speaking, the software should automatically generate from the reference points any equation, then you can print. Like this one is a beeping dog for babies, printed after scanning. Using another type of filaments, TPE, thermoplastic elastomer, for different physical properties like elasticity and or plasticity. List of polymers. We discussed earlier the ABS and the TPE filaments used in 3D printing. Others, like bakelite, which is polyoxybenzyl methylene glycol anhydride, a phenol formaldehyde polymer, hard, infusible, and a little bit ancient actually. Example of it is this Ericsson bakelite made telephone, but it's still used today in sockets for example. Polypropylene, which is a polymerization of propylene monomer, used almost everywhere, like bottles and caps, the plastic we all see everywhere in our daily life. Polyolefin, a polymer with general structure of CH2CHR, where R is an alkyl group, mainly used in plastic wrapping or shrink films. Polyvinyl chloride or PVC, this is very common in pipes, PVC pipes. Polychlorotrifluoroethylene or PCTFE, which has a lot of applications, for example the use in packaging of pharmaceutical pills. Polyethylene, this has a lot of types according to N, used for instance in Ziploc bags. Polyethylene terephthalate or PET with a trade name Mylar, used in bottles. Polyethylene glycol or PEG, this one has medical applications like eye drops and laxatives, and it's used also as a solvent and antifreeze according to its variety of molecular weights. Exactly the same thing for polypropylene glycol. Polyvinyl pyrrolidone or povidone, this one is usually added to iodine and used as an antiseptic. Polystyrene, trade name styropor, used in packaging goods. Polyurethane, different application of polyurethane like kitchen sponges or shoe soles, etc. Polyester, this one is used in fabrics and textiles. Aromatic polyester, trade name Vectran, again used in fabrics and in synthetic ropes. Polyamide, best known as nylon, used in stockings for instance. Polychloroprene, trade name neoprene, the best example of it is the latex rubber costumes, like diving suits. Polytetrafluoroethylene or PTFE, trade name Teflon, used in Tefal frying pans. Polyimide, trade name Ultem, in adhesive tapes. Polymethyl methacrylate or PMMA, which is an alternative to glass. Polycarbonate, trade name Lexan, this one is a hydrocarbon glass too, and it has a lot of applications, like the use in the production of CDs and DVDs. Polyisoprene, which is natural rubber found in the resin of trees. Polybutadiene is a synthetic rubber used in vehicle tires and car tires. Polyepoxide or simply epoxy resin in paints and glues. Polyphenylene 2,6-benzobisoxazole or simply Xylon, which has a lot of applications like the use in ping pong rackets or tennis rackets. Aramid fibers, like Technora in fiber optics. Para-aramid like Kevlar or Twaron in bulletproof armors. Meta-aramid, trade name Nomex, in firefighter suits. Back to recycling. Can we recycle 100% all of these polymers? The answer is no, because the carbon atoms will evaporate in the process in the form of carbon dioxide gas, according to thermodynamics laws. But it's true that what had to be recycled should have covered everything. Not only aluminum cans, for instance, what is best known for us all, but recycling clothes or maybe recycling cell phones. Imagine you can return everything you don't need to the recycling box of the shop you bought from, like your old phone or your old clothes, etc. Another thing that needs to be recycled is the recycling of nuclear waste. Imagine instead of burying all of the waste of the reactor in barrels underground for thousands of years, we reuse it in the reactor to the full, until we get a non-reactive lead, for instance. Thank you.